This is the review for section 3.2, identities. So multiply and simplify. Although we have trig in here, all we really have to do is FOIL. So first product will be 1 times 1 is 1. Outer product will be 1 times cosine, which is plus cosine x. Inner product minus cosine x times 1 is minus cosine x. And last product minus cosine x times cosine x is minus cosine squared x. So all I've done is first, outer, inner, last, FOIL. Notice the cosine and the minus cosine cancel. We have 1 minus cosine squared x, and that is sine squared x from Pythagorean identity. Nice. Next question. All right, factor and simplify the expression. Well, I see sine squared and sine squared. I see a like term, a like factor, sorry, in these terms. So I can factor out the sine squared x, leaving me 1 plus cotangent squared x. All right, cotangent squared x. There might be an identity there. I know sine squared x plus cosine squared x equals 1. To get a cotangent, I'd have to divide by sine squared x everywhere. Now the reason I'm doing this again is so that right here I'm creating a cotangent out of this fundamental identity. Simplifying, we have 1 plus cotangent squared x equals cosecant squared x. That's the identity we're going to work with. So plugging this in, we now have sine squared x times cosecant squared x. This is sine squared x times 1 over sine squared x. And we have these factors of 1. So our answer is 1. Almost too good to be true. Next question. Identify the equation as either an identity or not. Okay, so we're going to work on one side or the other, or both, just not simultaneously, to see if we can get one side to match up with the other side. Now, as far as hints go, I see 2 terms on the left and 1 term on the right. So if I work on the left side, I would want to combine these fractions into one common fraction so that I have 1 term on the left. That's the obvious step I'm going to take. Alright, so we're trying to establish if this is an identity or not. On both sides, they look like we could do something on both sides, but the right side is made up of sines, and those are the nice functions. The left side is made up of things that are not nice. Those are the functions I'm going to convert on all to sine and cosine on the left side and see what we get. So cotangent, that is cosine squared x over sine squared x. This is all divided by cosecant, which is 1 over sine x minus 1. So when we convert to sines and cosines, we get a complex fraction. A complex fraction is where the numerator and denominator each have fractions. The best way to clear a complex fraction is to take a look at the denominators. I don't really have a denominator here, but it's over 1. And look for the common of those, which is sine squared. Then multiply each term on the top and each term on the bottom by this sine squared common denominator. This is equivalent to multiplying by a form of 1. What this allows us to do is reduce. Now notice here we have 1 sine x. Here we had 2 sine x's, sine squared x. So I canceled the 2, leaving still the sine x. On the top, we have just cosine squared x. On the bottom, we have sine x minus sine squared x. Okay, now with cosine squared, I'm back to looking at the right side. No cosines. Cosine squared is 1 minus sine squared. So I didn't really know what to do on that step, except for I looked at where we were headed and noticed there were no cosines. And I have a nice identity for cosine squared x. Be warned, don't try to use this identity on just a cosine x. It doesn't work. It has to be cosine squared x. So we now have a situation where it looks like things factor. So on the top, we can factor out, as a difference of squares, we can factor it 1 plus sine x and 1 minus sine x. On the bottom, we can factor out the greatest common factor of sine x, leaving us 1 minus sine x. Factoring allows us to reduce this form of 1, giving us our final answer, 1 plus sine x over sine x. And that's where we're headed. We are done. This completes the review for 3.2.